Okay, we are doing lesson 7-1, understanding the Pythagorean theorem, and should be somewhat familiar, I think, to most of us, at least to some degree. So, understanding the Pythagorean theorem. We're going to start off with our warm-up question, just like always. Kelly drew a right triangle on graph paper. Kelly says that the sum of the areas of the squares with side lengths A and B is the same as the area of the square with side length C. Now, a couple things. First of all, I understand in your book, they didn't give you graph paper. They didn't put the triangle on graph paper. Is that true?
Yes.
Okay, so I don't know why it specifically says graph paper and then they don't put yours on graph paper. Mine's on graph paper. And so what we can see here on, let me find my writing utensil there. I can't see it. There it is. So what we can see here is line A here is 1, 2, 3 units long. So if I had a square, and I can even do, if I can find the right button. Holy biscuits. Okay. All right, right there. I can even do a square that works just like that. Look at that. 3 units by 3 units. Okay, and then we have a square that starts at B, that is line B is the side length. I didn't get that one too good, but close enough. And I mean, this is kind of a tricky statement, but you know what all these words mean. Kelly says that the sum, what does sum mean? We're going to add. We're going to add 2 things. So we're going to add the areas of these 2 squares. What is the area if the side length is 3? Well, if that side's 3 and that side's 3, then the area is 9. So we're going to do 9, and then this one has a side length of 4 and 4. Boy, that I don't know why that thing flashes back and forth like that. It's about to give me a seizure. All right, 9 plus 16, and that would equal what? 25. And so what we can't really tell from this picture is what this side length is. But what they're saying is that if we add those 2 squares together, it should be the same amount as if we had a square, and I can't, 1, 2, 3. This is not very good. I don't know, something like that. I don't know if I can do that with this or not. I'm trying something different here. Oh, I can kind of do it. It's not in the right place. Then I can move it. Oops. Ha! Abort. Oh my goodness. This is frustrating. Okay. Something like that. Okay. It should be that these 2 squares added together have the same area as that one square. It looks to be pretty close. All right. Now, it's hard to show just with a picture, and the next part of the warm-up question kind of helps us with it. The way they help us with it is they give us all 3 of the numbers. Okay, it's a different triangle, but if it's a right triangle and these measurements are accurate, then it should work. And so what we end up with is side length A, which is 5 squared, plus side length B, which is 12, and square it. It should equal side length C, which is squared.
So 25 plus 60,
So 5 squared is 25. 12 squared is 144. And 13 squared should be the same thing as 25 plus 144.
So
169. And 13 squared is 169. 25 plus 144 is 169. They equal the same thing. So that checks. That's exactly what happens when we have this one. So what is the side length of this square, by the way? If that area is 25, what's the side length of the square? 5. The side length is 5, and that's true. Okay? All right, so these two problems illustrate for us, demonstrate for us the Pythagorean theorem. Hopefully it looks familiar. We're going to go straight into kind of the examples that they give us here. If we had watched the video and made it through it, we would get to the end of it and have this problem to do, and the video is not worth watching. So we're just going to jump straight to this problem. A right triangle has side lengths 15 centimeters, 25 centimeters, and 20 centimeters. Now, one thing that the video does do that I probably should have shown at least that part of it, it labels for us the parts of a triangle, of a right triangle. Okay, I know that that angle is going to be the right angle because they'll put a square there. And this would be like side A, and this would be like side B. And those two sides will always make the right angle. A and B will make the right angle, and they're called legs. Legs, just like you got 2 legs and a triangle has 2 legs. Right triangle has 2 legs. This side, side C, will always be across from the right angle. It will never touch the right angle. It will always be across from it. It's always going to be the longest side of the triangle, and it's got a special name. Anybody know what it is?
The head. Body. Neck. Arm.
Hypotenuse. Okay, so it's one of the funnest words we get to say in math, and it's hypotenuse. Hypotenuse. All right. So you're going to see that word. You need to know what it means. Hypotenuse, the long side of a right triangle. So, guys, this is super simple. The two shorter sides, the two smaller sides will always be A and B. They need to go together. And so even though they don't label them as 15 and 20 being the legs, I know they have to be the legs because they're the two shorter sides, the two smaller numbers. So 15 squared plus 20 squared should equal 25 squared. Well, 15 squared is 225. 20 squared is 400. And guess what 25 squared is?
625.
625, exactly. Okay? So it's true. That means this is 100% for sure a right triangle, and the numbers work. All right? Is that, so far, have we done anything like super tricky?
No.
I don't think so. It's not going to get too much trickier than this.
When do we have a test?
Not today. Not tomorrow. What is the length of the hypotenuse on the right triangle? We also can use the Pythagorean theorem to find the missing lengths of various triangles, various right triangles. If we know it's a right triangle, the Pythagorean theorem will work. And so I know a squared plus b squared has to be equal to c squared. It has to be true. So all I got to do is do 8 squared plus 15 squared, and it's going to equal c squared. We'll solve this in a couple of steps. It's not hard. What's 8 squared? 64. What's 15 squared?
225.
225. And it's going to equal c squared. 64 plus 225 is 289. And now what do I do to solve it? Take the square root. So square root both sides. Square root of 289. Your calculator is going to be your friend on this lesson. Square root of 289 is 17. So C equals 17. That means the hypotenuse of the triangle is 17 centimeters long.
And the legs are 15 and 8?
Yes? Okay? All right. Again, have we done anything super tricky?
No.
Really, we haven't. It's just some simple equation solving. All right. Here's another one. What if we know the hypotenuse and we know one of the legs? Can we find the other leg? I think so. Mara is repairing the trim on one side of a display case that she sketched, that is sketched here. She has a piece of trim that is 20 inches long. Does she have enough trim to repair the display case? Well, we need to do a squared plus, she's got one side is already 20 inches, so we'll do 20 squared equals 29 squared. A squared plus 20 squared is 400. And 29 squared is 849? 841. 841. Subtract 400. So a squared equals 441. Take the square root.
441 squared.
So a is 21. Does she have enough trim? She has a piece of trim that's 20 inches long. Can she repair that side? Nope, she needed 21 inches. So it won't work. Phooey.
I mean, could you just make it like a little bit thinner?
No.
Oh yeah, just shave off the side.
You could change the size of your triangle, I guess, but you can't stretch the board that needs to go in that spot. All right. One more. A right triangle has a hypotenuse length of 32 meters. It has one leg with a length of 18 meters. What is the length of the other leg? So, guys, they don't give you a picture. Draw one if it helps. I usually will. There's my right angle. They say the hypotenuse is 32. They're telling me that's the long side, 32 meters. They're saying one leg is 18 meters. Does it matter which one I mark as that leg? I could have marked 18 here. It doesn't matter. Your triangle doesn't have to be to scale. All right, so now I just need to find the length of the other leg. So 18 squared plus b squared equals 32 squared. So 18 squared is 724? No, 324. My bad, 324. Plus b squared equals 1024. Subtract 324. B squared equals 700. How do they say to express the answer? As a square root. If you put your calculator square root of 700, it's like 24.5 or something like it. It's not a rational number. It comes out to an irrational number. It is not a perfect square. And so if we can't leave our answer like that. They'd say express your answer as a square root. So we're just going to do this. Then we're going to say b equals the square root of 700. And that's it. If you typed in the answer 24.5 or whatever it is, then they would count that wrong. They don't want you to round it or estimate it. They want you to leave it as a square root. So follow the directions if it says to enter your answer a certain way. Okay, guys, that's the lesson. Can you do a squared plus b squared equals c squared? And use that to find missing side lengths of a triangle? I hope you can. That's the main thing you need to do today. Your assignment, I believe, is pages, 400, 401 or 399, 400. 399, 400. So pages 399, 400 is what you need to work on today.